Welcome back guys once again to this atomic and molecular physics quick revision. So this is the fourth part, and in this fourth part we'll be talking about hydrogen fine structure and spin orbit interaction. So hydrogen fine structure, the origin of hydrogen fine structure consists of different types of regions. One of the most important region is this spin orbit interaction. The spin orbit interaction is solely responsible for this hydrogen fine structure. So without any further ado, let's just start. So in this picture you can see a very good presentation has been given of hydrogen energy level. You can see n equals to 1, n equals to 2, n equals to 3. As you go on to higher n values, the energy levels becomes closely spaced. We can only see the visible part of the spectrum. Now here you can see, if you just zoom it out, if you just zoom it, let's say 100,000 times, then you get to see higher fine structures, hyper fine structures. Okay, and this n is equals to 2 level. When it is further seen, it is composed of 2p3 by 2, 2p half. Then this 2p half again composed of 2 lines, and you get lump shape. This is not the scope of this video. I am just telling you, just for your understanding. We can discuss this lump shape and all those things separately. That leads a lot of investigation into the subjects. So some other things are there, you can just watch it. I am not explaining it. Our main topic of discussion today is spin orbit interaction, and questions may come from this spin orbit interaction. So let's talk about this spin orbit interaction. This one we have taken from Rajkumar's book. Rajkumar's book you can refer as a standard book for atomic and molecular physics. That is very atomic physics actually, very good book. Molecular physics also there. Sommerfeld was the first who attempted to explain the observed fine structure of hydrogen spectral lines by introducing the relativistic variation of mass of the electron. Electron being a light particle, if it is traveling with a very high velocity, it becomes relativistic, and because of this relativistic variation, mass does not remain constant, and as a result of that, this fine structure constant may be originated. This was the thought of Sommerfeld. Okay, according to Sommerfeld, the electrons revolve in an elliptic orbits rather than circular orbits. Sommerfeld was fairly successful in his mission. A more perfect account of the observed fine structure is, however, given by quantum mechanics. Okay, Sommerfeld's theory was semi-classical theory, right? So it had some failure, but quantum mechanics provided a proper explanation to the spin orbit interaction as well as the relativity correction. So let's talk about this spin orbit interaction. Spin orbit, as I told you already, spin orbit interaction is the interaction between the electron spin magnetic dipole moment and the internal magnetic field of an atom, which arises from the orbital motion of the electron through the nuclear field. So let me just briefly tell you what it is. So electron is revolving around the nucleus, and because of this orbital motion, some kind of internal magnetic field is generated, and this internal magnetic field is acting with the spinning of electron. In addition to revolving around the nucleus, electron also show some spinning motion, okay, that give rise to the spin orbital momentum. So this interaction between the originated internal magnetic field because of the orbital motion and this spin magnetic dipole moment, this is called as spin orbit interaction. Since the internal magnetic field is related to the electron's orbital angular momentum, this is called spin orbit interaction. So basically you remember LS interaction, and it is relatively weak interaction but responsible partly for the fine structure of the excited state of an electron. As I told you earlier, spin orbit interaction is not the only reason. There are some additional reasons, but in this video we will be talking only about the spin orbit interactions. So let us just write few lines. The spin orbit interaction causes each term or energy level of a given L to split terms of different gauge, total angular quantum number. One is displaced upward, one displaced upwards, and another downwards. What it is meant? Look, let me try to explain it for you. Okay. So this is a particular line with particular L value. So because of the fine structure or this spin orbit interaction, it will be splitted into two values having different L. Okay, one is termed as delta T LS double prime, delta T LS single prime, and this separation is known as the term shift delta T. Okay, so one displaced upward, another one displaced downward. So what is the difference? The difference between them is given by this value of delta T. So this is equals to delta T LS double prime minus delta T LS single prime, and I am not going to derive it, but I am writing the final expression which you should remember, that is R infinity alpha square z to the power 4. Alpha is a fine structure constant, z is the atomic number, n cube principal quantum number, L orbital quantum number, L into L plus 1. So R infinity alpha square z to the power 4 divided by n cube L into L plus 1. What is R infinity? R infinity is the Rydberg constant by considering the infinitely heavy nucleus, 1.097 10 to the power 7 meter inverse. And what about alpha? Fine structure constant 1 upon 137. These values you should remember because these values frequently appear in your calculations and everywhere. Now a more simplified expression, this is in terms of energy. So you know, in atomic and molecular physics we always write most of the time in terms of meter inverse or centimeter inverse. So its value in meter inverse is 584 z to the power 4 divided by n cube into L into L plus 1. By putting the values of this alpha R infinity, we get it in terms of meter inverse like this, and if you want to write it in terms of centimeter inverse, we just write 5184 z to the power 4 divided by n cube L into L plus 1 centimeter inverse. If you cannot remember this whole formula, you at least remember that this term shift, because of spin orbit interaction, it is proportional to z to the power 4, it is proportional to 1 by n cube, and it is proportional to this 1 L into L plus 1. So if you remember this, that is enough for you. Let me show you one problem that will help you understand like what kind of problem you can expect. This problem came in December 2017. Look at this problem. If the fine structure is splitting between 2p3 by 2 and 2p half, you know where are these levels? 2p3 by 2, 2p half. In the first slide I have told you n equals to 2, so this gives rise to 2p3 by 2, 2p half. These two levels because of the fine structure splitting. Levels in the hydrogen atom is 0.4 centimeter inverse. The corresponding splitting in lithium 2 plus is. So very simple problem. You know delta E or term shift is proportional to what it is proportional to? Z to the power 4. Okay, Z is different for hydrogen and lithium, right? So delta E, if you calculate for lithium and if you calculate for, let's say, hydrogen, this will be equals to the ratio of their atomic number with power 4. So hydrogen, helium, lithium, so Z is equals to 3 for lithium and hydrogen 1. So 3 to the power 4 is 27 into 3, 81. So your term shift for lithium will be 81 times greater than the term shift of hydrogen. For term shift of hydrogen is given to you 0.4 centimeter inverse. So term shift for lithium will become 32.4 centimeter inverse. That is matching with option C. So in this way you can easily calculate the term sheet. I hope if any questions come from this finance structure, you will be able to easily able to solve by remembering this particular formula. Okay, so this is all for this video, guys. Let me tell you before I end this video, let me tell you this unacademic goal: stay ahead in your preparation journey. We have taken all of these sessions in detailed course in a detailed manner. Here I am just giving a glimpse of whatever is there. Anyways, this offer is valid till May 31st. You can go for CSIR-NET June 2024 or December 2023. So you have to utilize the referral code Physics Hub for getting the maximum benefits while taking the subscription. This is our profile on Unacademy Plus and Iconic as well. You can get all the 9 units of CSIR-NET Physical Science in English language from Unit 1 to Unit 9. All the 9 units you can get by taking a single subscription using this referral code Physics Hub. And lot of benefits are there of taking an Unacademy Plus subscription. You get daily live classes, part length, full length assignment, GL solution, proper structure course, whole syllabus is and many more benefits. You can pause and read it. So this is all for this video, guys. Thank you very much. If you are new to this channel, please subscribe to the channel and don't forget to press the bell icon. Finally, thanks for watching.